This one is the application of definite integral to economics problem. Okay. So for number one, the bequest continuous constant income stream is 4,000 per year. So the rate is 4,000 per year. The duration is the next 10 years, and the interest rate is 4.4, compounded continuously. Okay, so for these section we use the formula for the continuous present value. Okay, so what is the present value of the bequest? So for number one, okay, let me label number 1, 2, 3, and 4. So for number one, okay, so we want to find the present value for the bequest. For the next 10 years. So this is given by integral from 0 to 10, and the rate, continuous constant rate, 4,000 times e to the minus the interest rate is 0.044 t dt. Okay. So if you compute this integral, then using the fundamental theorem of calculus 4,000 times, you can bring the constant outside. The antiderivative of the exponential function is negative 0.044 e to the negative 0.44 t. Okay, from 0 to 10. So 4,000 times, let me simplify a little bit. Okay, the denominator 1 or negative 0.044 is the constants. Let's bring out the bar, vertical bar. Then this constant from 0 to 10 by the fundamental theorem of calculus e to the negative, oh okay, there's a copy mistake. E to the 0.44 minus plug in 0, plug in 10, e to the negative 0.44 minus plug in 0 is 1. Okay, this number, you can simplify it. And the second question, how much money would bequest be worth? This is the future value. So for number 2, bequest. So we have present value. So future value is just nothing but p times the present value times e to the rate times duration. Okay, so you can simplify it. So this is equal to 4,000 divided by negative 0.044 times e to the negative 0.44 minus 1 times e to the minus 0.44. Okay, you want to simplify this. I'm sorry, there's a mistake. It's just R. Okay. So this is equal to, I can simplify further. Just expand 1 minus to the 0.4. Okay. And use calculator to the decimal. So number 3, now the CD offering a little slightly bigger interest rate, okay, also compounded continuously. Then what is cost of CD, which means that this is the present value of CD. So this is okay, 1 second. This is okay. So we wanna set an equation, the same amount of the money as the bequest after 10 years. Cost of CD. So we're assuming that this is one-time lump sum payment. The cost of CD. The cost of CD, so which is the present value. So the present value of the CD for the lump sum, present value of the CD equal oh no, sorry. So we're going to compute the present value of CD. So and the future value of CD is equal to the same amount of the money as the bequest of 10 years. So this must be equal to B bequest, the future value of the bequest. So BCD is equal to present value of CD, which we want to find, times e to the 10 times rate. Sorry, the rate is 0.049, 10 years. This is the future value of CD. B sub CD is equal to B, the future value of bequest. We computed. So we use the result from the second, the part 2, which is 4,000 divided by negative 0.044 times 1 minus e to the 0.44. Okay, then solve for PCD. That's number 3. And 4. Okay, US got to pay the difference between the difference you want to compute the difference between the present value of the original bequest and the amount of invested in the CD. The amount invested in the CD, which is the present value of CD. So we want to find the difference. Because CD is more profitable, we can assume that the present value of CD is smaller. So the difference is the absolute value of P bequest minus PCD. Okay, take absolute value. Okay. So you can use the previous result from 2 and 1 and 3. Okay. Number 2, the future value is this much. We want this much in 9 years, and the interest rate is 9.5% and compounded continuously. So you want to find constant continuous rate. Must the parent deposit money into the account in order to save that money. So So we want to find S in the formula. Remember that the present value for this constant rate is from 0 to the period times S, the constant rate e to the minus RT dt. Okay. So in this case, the present value is from 0 to for the next 9 years. And S is unknown. We want to find e to the rate is 0.95 t dt. Okay, let's compute this one. Then S is constant. And from 0 to 9, e to the negative 0.09 t dt. So this is equal to S times the antiderivative 0.05 e to the negative 0.095 0 to 9. So this is equal to S times S over minus 0.09 constant and e to the negative 0.09 times 9 minus to the 0, oh, t is here, sorry. So this is present value. Now let's continue. So the future value, be equal, we want to achieve 85,000 in the future, after 9 years after. This is equal to present value times e to the 0.095 times 9 years. Okay. So present value we computed, just computed, so plug in S over minus 0.095 e to the minus 0.095 9 years minus 1. So we have an equation. So let's simplify. 85,000 equal okay, multiplied by I forgot multiplying by e to the 0.0959. I'm sorry. Okay, so this is equal to S over minus 0.095 times. Let's expand this out. This time this is 1 minus e to the 0.095 times 9. Okay. Then solve for S. S is equal to 85,000 times minus 0.09 divided by 1 minus e to the 0.0959. You can simplify it. Okay, this is for part A. For part B, if the parents instead deposit a lump sum now, how much must deposit to attain the goal? So for the lump sum, the future value is just P equal present value lump sum times e to the interest rate is same 0.095. This is future value 9 years after. 9 years later, this is equal to 85,000. So P, the present value for the lump sum, is equal to 85,000 divided by e to the 0.0959. You can simplify it. Okay. The next question, number 3. Okay, between this period, the payment rate between this period, the net profits, which is payment, will deposit, is given by this. This is ST million dollars per year. Okay, the rate is given by the linear function. And this time in years since 1992. Find the value in 1992. So which is present value over the next 5 years period. Interest rate is 4%. Again, always compounded continuously. So the present value over the 5 years period from 0 to 5 and ST plus e to the negative, the rate is 4%. Okay. So use your calculator to compute it. Number 4, find the present future value of the constant income stream. The rate is constant, S equal 50 to 100 over the 9 years period. Interest rate is 30%, compounded continuously. So number 5, find the present value of the income. So we use the same formula. So integral from 0 to 9, S is constant, 50 to 100 e to the rate is 3%. Okay, in this case, you can use calculator or as double by hand. So, and the antiderivative is this one, e to the minus negative 0.03 t over negative 0.03 from 0 to 9. This is equal to 50 to 100 plug in 9 e to the negative 0.39 minus plus 1. We can simplify it. So this is A. The future value. So we have the present value. We use the result from A. So future value is B is equal to present value times e to the 0.039 years. Okay. And see how much the future value is from the interest. Okay. So this is just difference between the result from B and the result from A. So just the P e to the 0.039 minus P from A. So this is just P times e to the 0.039 times minus 1. Okay. Number 5. Okay, the payment now is a linear function. For the next 10 years, interest rate is 6.25%. Compounded continuous. Okay. Now S of t is not constant. Present value by the formula interval from 0 to 10 years, S of t plus 13t times e to the negative 0.0625 t dt. So use your calculator. Okay, for number 6. Okay, so the revenue at the continuous rate. So the payment this much per year. The rate is given by this linear function. during the first 6 months of the operation, and then at the constant continuous rate. After 6 months, 76,000 per year. After the first 6 months, the cost of the machine is 155,000. The interest rate is 6.75% per year, and again compounded continuously. So the S of t is 66,000 t plus 43,000 for the first 6 months, t in months, okay, 6, and st equal constant 76,000 per t greater than or equal to 7. Okay. So number 8, find the present value of the revenue earned by the machine during the first year. The first year of the operation, so 12 months. You need to convert the unit. Okay, so but note that the ST is not changes after 6 months. So the present value is given by for the first month from 0 to 6, 66,000 plus 43,000 e to d. The rate is negative 0.0675 TDT plus after 6 months, I need more space. Okay. Plus 6 to 12. The payment rate is constant, 76,000 e to d. The interest rate is the same. Okay, so use your calculator. Number B, how long will it take for the machine to pay for itself? That is, how long until the present value of the revenue is equal to the cost. Cost is given 155. So let's say this is the first component from A. Say this is P6. This is P12. Okay. So if P6 is bigger than 155,000, then the year for which the present value of revenue is equal to the cost is less than 6. Okay, so t is less than 6. So set this equation from 0 to t, 66,000 t plus 43,000 e to the negative 0.0675 t dt equal 155,000. Then find t. Okay. If P6 is less than the cost, then T is bigger than 6. So set the present value of P6 plus we need more months. Okay, press from enter from 0 to 6, from 6 to T, 76,000 e to the negative 0.0675 T dt equal the cost. Then solve for T. Okay. And number 7, at what constant continuous rate when it deposits, the payment is constant rate. If the account is contains, okay, the future value is 23,000 in 15 years. Interest rate is 3.5 compounded continuously. Okay, so the future value is 23,000. So first, let's compute. First step on compute the present value. The present value is equal to from 0 to 15, and the constant rate, payment rate or deposit is unknown. You want to find this. S times e to the negative 0.05t 0.35 tdt. So let's compute this one. Okay, S times the antiderivative of this exponential function is denominator is negative 0.05 and e to the negative 0.035t from 0 to 15. So this is equal to S over negative 0.035. These are constant from 0 to 15. So e to the negative 0.035 15 minus 1. Okay. Then step 2. Using this, let's compute the future value, which is we want 23,000. P equal P e to the 0.035 15 years later. So set this equation. So P is from the part 1, from the step 1. Negative S over negative 0.035 e to the negative 0.035 15 minus 1. So we can solve for S. Okay. Okay, so I forgot this. Multiplying by 0.035 t. Okay, then we have this equation. Solve for S. S is the only unknown. The next question, ABC's rate of sale is given by exponential function. This is ST. And since 2006, hold true. This rate is holds through 2006. So 6 years period. Interest rate is 7.4% compounded continuously. Find the value in 2000 of the sales. So this is present value. So again, by the formula, P equal from the 6 years period from 0 to 6, and ST is given by the exponential function on 1326 e to the 0.155t times ST times e to the negative 0.075t dt. Okay, so we're gonna compute this one. This is 1326. You can plug in your calculator, or you can simplify a little bit. So this is exponent with the same base, just add the exponents to simplify it. So 0.8 t dt. So this is equal to 1326. The antiderivative is e to the 0.8 t divided by 0.8 from 0 to 6. So this is equal to 1326 0.8 e to the plug in 6 minus 0.8 plug in 0.1. So simplify it. Okay.